Recording 3, a little more near and dear to somebody's heart. Me. Okay, we're going to talk about, not do the statistics here, but actually a situation that I actually ran into, an asthma study. So as you all know, I do health psychology research in asthma. And in 1998, I ran my first asthma study, and we gave people asthma. You guys in OT and PT and PA and nursing do quality of life things? Mm-hmm. Yeah, that's what we did. We had an asthma quality of life scale. And the asthma quality of life scale basically said it's a 7-point scale that if you run a study and you get people that are a half point better on the 7-point scale, that is clinically meaningful. That's really important. That means it, hopefully better, that it really did help them out. And so in 1998, we ran the study, the educational interventions. I had only 6 people, measured their quality of life before and after. What kind of design is this?
The within subject intervention.
Within subject intervention design. Previous researchers who used this scale and developed it, it was reliable, it was valid. They did the factor analysis and that whole thing. The survey included statements such as, during the last few weeks, felt tired, had wheezing attacks. There were about 13 of these. Take a look, though, at the final column here. Does it look like I have anything here?
No. What?
I don't have anything statistically significant because the value for the final column would have to be what? 0.05 or less than 0.05. Do I have anything close?
Yes.
Do you remember, did I use that term last week?
Margin.
I have a couple of results that are marginally significant. It looks like for chest tightness, restriction in sports. Don't worry, I took my albuterol before taking the 60-mile bike ride on Saturday. For those on the recording, I actually did do that. So, how come I didn't get anything really significant here? What was the problem? It wasn't a large enough sample. What we would say statistically is this study lacked power. Exactly the case. I did not have enough power to detect significant differences. Were some of the treatment effects pretty good here? Look at those treatment effects. Is that the numerator or the denominator?
Numerator.
That's the numerator. And what did previous research say?
Difference in the mean.
If the difference is more than 0.5, do I have differences greater than 0.5 here? Yeah. So if I had concluded on the basis of the 98 study, my program doesn't work. Statistically, did my program work in 98?
Don't know.
We don't really know. If I make the conclusion that it didn't work statistically, what kind of risk do I run?
Discontinuing ineffective treatment.
Say again?
Discontinuing ineffective.
Yeah, I might actually stop the program. But I could have a mistake here. I might have what we call in statistics a type 2 error. Have you heard this term before? A miss. My program might really have worked, but I missed it. And why did I miss it? Because I didn't have enough people, but we wouldn't say people, we would say the other P word. I didn't have enough power. My sample size was too low. Don't worry, people was good too.
Thank you.
We'd be client-centered. People first.
People first. I didn't have enough power in my study. So what would you have me do? In 1999,
More subjects.
I would run the same thing again. Did I do that? Yes, flip the page.
That looks better.
That looks a little better. Is everything significant there?
Yep.
Yep.
Indeed.
How many more people did you get?
I just had 6 more people. So 12 isn't even a lot of people anyway. But we basically met once a week for 6 weeks. And by the way, I don't know if I said this last week, I actually had a few OT faculty working with me on this because asthma kind of affects quality of life things and doing things. So I actually had a few OTs at Jefferson College, if anybody knows Ave Mita or Karen Lehman. They're kind of OTs. Karen was kind of involved in this particular project. From an OT perspective, we had respiratory therapy people involved as well. If you look at these different columns, the treatment effects, all very large there. Standard D, do we want that number to be large or small?
Small
Small, because standard deviation reflects
variant,
variant, error.
yeah.
We want that to be small. The T-scores were larger. Sample size was more. They were all significant. So we had, in this situation, power. We had enough power. Even 12 people isn't very many.
So how do you advise us in being able to predict or project the level, if we're okay in power when we're planning a study?
So when you're planning a study, it's a good question. When you're planning a study, and we'll look at some articles a little bit later, the articles that we will look at talk about effect size, which is kind of related to the numerator, but a little bit different. And what you can do, you can look at the effect size, and then there are programs, and I actually have one on my computer, it's called G-Power, and you can say, here's what I expect the effect size to be, and you can say I want 80% power, two-tailed, and it'll say, here's how many people you need. And that's how we play that game. So you have to kind of estimate, based on previous research, what you think the effect is going to be for the treatment or the effect size, and then you can just plug that into a simple program, and it'll say you need this many people. 80% power is considered what most people, kind of the baseline standard of things. Does that kind of answer things? Okay.
It means I need G-Power in my life.
What's that?
So it means we need G-Power.
Yeah, I have the program. It takes 5 minutes to put it in. I think it's free. So let's stop the recording.